Hey everyone, Arthur here from OneTech. Today we're going to cover the MicroAI Atom Raspberry Pi Security SDK, and we're going to do an end-to-end demo showing exactly what you need to do to get the SDK up and running, everything you need to run, and some cool applications of it. So, as you may know, MicroAI is an AI engine in which you can feed all different types of information, and out of it, all different types of applications can be built. So, in this video, we're going to cover the security use case. So all of this information and the entire SDK is in the MicroAI GitHub. In that GitHub, you can also see many different documentations on what exactly MicroAI does and how it can help you and why you should use it for your use case. So one of those documents is, for example, this user guide, where we go through everything of how exactly to run MicroAI and the specifics of getting started with it. If you follow this document, everything from the dependencies you need to install and how you need to set up your machine, all the way to a step-by-step guide of how to run all the executables and configure things to the end of actually getting your use case up and running is covered in here. So you follow the document and you'll get all that up and running, just going step by step. Some other documentation in there is our license, where you can learn a little more about the terms and limitations. So here is a top level view of the SDK directory. In this directory, you can find all types of information on how to run MicroAI and how it can help you, and other details about the use cases as well. Along with that, of course, are the executables and program files to run the data acquisition engine and applications for MicroAI and get started doing that. So the next steps for us are to run some of those files on our Raspberry Pi. So I have this directory for the SDK on a Raspberry Pi. All I need to do is now go to my command prompt on my computer and SSH into the Pi so I can start running some of these programs via command line. So here I have the session and I have a Tmux window open, broken up into a few different smaller windows so that I can run everything and see it all at once. So the first thing that I'm going to run is the attack tool, because basically I want to run everything before I run the AI engine. Since this is security and security is monitoring all this computational performance metrics, then I want to make sure that when security is running, everything that could be affecting those metrics is running in the background. So one of those things will be the attack tool, which we use to test the security output and see how our applications change based on some sample attacks that we run. So let's go ahead and get started with that. So this is the security directory on command line, the actually whole MicroAI Atom directory. We'll go into the security subdirectory. And then we will go into the attack tool. First, we're going to run the initiator. It's a part of the attack tool. It's just in two parts, the initiator and command center. And the initiator just sets up the device so that it's ready to receive those sample attacks that are run via the command center. So first we go into the initiator directory. Excuse me. Then we are going to run that initiator.py file. All right, then we can go down, do the same thing to run the command center, cd to security, cd to attack tool, cd to command center, and then run that command center py file. There we go, we have it already. So for this demo, we'll run a cryptojacking attack, but not yet. First, we have to run the other parts of MicroAI. So next, we're going to run the data ingestion, or Xcode. This is the code that's going to send all of that computational performance data to a place for the AI engine to be reading it. So in the APM use case, you can pick and choose what you want to go in your Xcode and feature engineer. So you're picking all different types of sensors, humidity, temperature, pressure, or anything else, and change with it as much as you want. Of course, within the SDK limitations of 6 channels. So the for security, however, to keep things secure, we do not actually expose the Xcode. So all you need to do is just run that Xcode, and then those computational performance metrics that we monitor, many of which to really get a great idea of what's happening in the device, will be sent to a place that can be fed to the AI engine. So let's go back into security. This time we'll go into the X subdirectory, and we will run that signal source executable. There we go, Xcode's running. Now we can go to run the AI engine. So I'm going to cd into the AI engine subdirectory. And before I run the AI engine, I just need to check a configuration thing. So first, let me go into root cfg. This is the configuration file, where basically I need to decide whether I am going to be building the model or executing the model. So for the first time, you need to build the model, and then you can build it. And even in this file, you can change how long you build it for based on the sampling time and the overall time. But also, if you're not building it, then you can choose to execute it. Basically, just with these 2 parameters. So if I want to build it, I need to set it as build model equals 1 and execute model equals 0. And if I want to execute it, I need to set it as build model equals 0 and execute model equals 1. So how it is now. So I already built this model earlier, so we are good to go. We don't need to wait through building it again. So this file is ready for us. Now I am going to run that AI engine executable. There we go, and we got the AI engine running. So other thing to run would be the Y code. So this is the application code. And we have a very simple Y code for demonstration purposes. So let's go ahead and go into that. All right, so now I'm going to go ahead and check out what exactly my Y code looks like. So as you can see here, it's just a very simple use of the MicroAI network output library. We're importing a function, and there's a function there that's abnormal ratio. So abnormal ratio is just going to tell us based on how the AI is looking at the channels and seeing whether things are normal bounds or outside of them. It's going to tell us a little ratio of how it's doing. If the number is high, that means that a lot of things are seeming very abnormal. If it's low, that means that things are okay. So basically, with this Y code, all I'm doing is I'm printing that every second, that abnormal ratio. So you can build on top of Y code and do all different types of things to it, trigger things in many different ways, can have many different checks, and even incorporate all types of other aspects of MicroAI, especially beyond the SDK, like groups and different, and do horizontal analysis or vertical analysis, build all types of visualizations and workflows, even from your own files. But this is just a simple Y code just to show things in action. So let's go ahead and run that. Python. All right, and so right now things are looking good, but since the engine was just started, we might see a few fluctuations here and there. So, but for the most part, we're in good shape. So everything is running now. And one other thing to show is something beyond the SDK, which is our dashboard. This is a Helioserver dashboard where basically you can see many different things about what exactly is happening, and it takes data from MicroAI. So using our own protocol, we're able to send it to the cloud and see live data come into the dashboards. So for example, that's what we're going to have coming in here as well. As you can see, the values are changing. So as things normalize out, as more is being run, then things are going to seem a little bit abnormal. We might get some fake events, but let's go ahead and run an attack. As soon as we see things seem pretty normal, we should be able to get going. So, all right, now things seem to have normalized. Let's go ahead and run an attack. So we were running the cryptojacking attack. Attack is happening, so let's see how things happen on the dashboard. So things, as you can see, they go out of bounds to show crazy values. And we got a new event generated, and we saw some abnormal behavior over here as well. It's just showing that MicroAI is detecting these things happening, and now over time it will normalize. The dashboard will. So then we can move on and catch the next event as it happens. So that's the full MicroAI demo for the security use case on Raspberry Pi. So please check out the onetech.ai website as well as the OneTech GitHub for more information and to learn more about deploying MicroAI yourself. So have fun working with it and happy coding. Thank you, everyone.